Hello everyone. So today we are going to talk about CSAT previous year questions and we are going to discuss CSAT 2023 Logical Reasoning, and this is the second session of CSAT LR 2023. So let's see and let's solve few questions of CSAT LR. Okay. Now, consider the sequence, and we have this sequence, and question is saying it follows a certain pattern, and how does it complete the pattern? Okay, fair enough. So basically, what is it that is given to us? That is A, then B, then C, then there are two spaces. Then I have A, B, C, okay. Then again some space, then D, okay. Then A, then B, then B, then C, then D. Okay, so this is what that gives us clue. ABC is there, ABC is there, okay. And again in the next one, there is a space, then ABCD. Okay, so again ABC is there. Okay. Now what is happening over here? B is coming twice, and here basically if you see A, B, C, then there are two spaces. Then again ABC starts. Then one space, then D, then A, B, B, C, D. It means if you see there are two B's, then if I put two A's over here, so A, B, C, D with one extra alphabet. So basically it should start as A, B, C, D, D, A, B, C, C, D. So D is coming twice in the first pattern, C is coming twice in the second pattern, B is coming twice in the third pattern, and A is coming twice in the fourth pattern. So basically it is A, B, C, D plus one additional alphabet starting with D, then C, then B, then A. So at first place, I'm going to plug in D, then again D, then I'm going to plug in C, then I'm going to plug in A. So D, D, C, A should be my answer, and that is going to be my option A. So to approach these kind of questions, just try to grab little hints that are given. Try to find similarities that are non missing values, and accordingly proceed to that. Now let's move on to the next question. What does it say? So it says A, B, and C, D are two-digit numbers. Okay, multiplying A, B with C, D results in a three-digit number D, E, F. Okay, so that's a tricky part. So I am going to say that A, B into C, D, and that is equal to D, E, F. Now important point is this is D, this is also D. So second digit of the second number is the first digit of the product. That's a good information that is given to us. Now adding DEF to another three-digit number, GHI. So basically D, E, F plus G, H, I, and that results in 975. That is given to us. Okay. Further, A, B, C, D, E, F, G, H, I are distinct. Okay. So I am going to write A, then I'm going to write B, then I'm going to write C, then D, then E, then F, then G, then H, then I, and all of them are distinct. Now, this is a very crucial and very important information that is given to us, that E is 0 and F is 8. Okay. So I am just rewriting this statement, that is AB into CD is equal to D 0 8. Okay. So if I multiply this and this, I am going to get 8. So I need to figure out the two digits that are going to give me a product as 8. Unit digit should be 8. So one can be 2 into 4. Okay. Then it can also be 4 into 2. So if this is 4, this number is going to be 408. Okay. If this is 2, this number should be 208. Okay. Now we can have 4 sevens are 28. 7 twos are, sorry, 7 fours are 28. So basically, uh, B can be 7, D can be 8, D can be 4. So basically, this might work out. Okay. Then it can be 1, it can be 8. That is again a possibility, but I won't consider this as a possibility because D is 8 and F is also 8. That's not a possible solution, so I am rejecting it. Similarly, I can also reject 8 into 1. Okay. Now it can also be 9 into 2, or it can be 2 into 9. So basically these are all the possibilities for the unit digits, the product of unit digits that are going to give me product of unit digit of 8. Okay. Now I am going to come to this. Okay. Now D is D, E is 0, F is 8. Okay. We got G, we got H, we got I, and that is equal to 975. Okay. Now if this is 8, 8 plus what will give me 5? So basically I should be 7. So 8 plus 7 is 15, carry over is 1. Now 1 plus 0 plus H is 7, so H must be 6. So this is what information that I'm getting. Now carry over is 0. So what else we are getting? So basically we are getting E is 0, F is 8, I is 7, I is 7, and H is 6. H is 6. Okay. Now, if D is 4, if D is 4, then G will be 5. Okay, looks fine. If D is 2, G must be 7. So if D is 2, G must be 7, and G is 7 and I is 7, both cannot be true. It means D cannot be 2. So D cannot be 2, D is rejected. Okay. So D is equal to 2 is a possibility that we have rejected. D also cannot be equal to 7, right? Because I is 7. This also cannot be true, so rejected. Okay. Now if D is 9, if D is 9, so 2 is rejected, 2 cases already rejected. If D is 9, G is going to be 0. If G is 0, then it can't be a 3-digit number, so this is also rejected. The only possible outcome is 2, 4, and this number is 408. So I got this is 2 into 4, and that is equal to 408. Now how can I get it? So basically one number ends with 2, another number ends with 4, and product is 408. So it can be something like mm, 34 into 12. So 34 is 34 into 12. I'm just guessing. So 34 into 10 is 340, plus 34 into 2 is 68. Total product comes out to be 408. So this gives me every value nicely. So this is going to be 1, this is going to be 3, and question is talking about what is the value of A plus B plus C. So 1 plus 2 plus 3 is going to be 6, and that's the answer of this question. And that's how we are going to approach this question. More or less we are going to eliminate all the possible combinations and proceed accordingly. Okay, now let's move on to the next one. What does it say? A cuboid of dimensions 7 is to 5 is to 3 is painted red, green, and blue. Okay, so what I am going to do, I am going to draw a cuboid that has dimensions as red, green, and blue. Okay, so this, so basically this is 7, this is 5, and this is 3. Okay. Now what does it says? Red, green, and blue on the opposite on each pair of the opposite faces of the dimensions 7. 7 into 5, 7 into 5 is the front one, so that is going to be red. So basically this front one is red, this is also red, so front and back are red. 7 into 5 is red. Okay. 5 into 3, 5 into 3 means this side one, so this is what, green. This is also what, green. So this should be the front one is red. Okay. Then 7 into 3, 7 into 3 is bottom one, that is blue, and the top is also blue. Okay. Then the cuboid is cut and separated into various cubes of side length 1. Okay, fair enough, that's fine. Now question is saying there are exactly 15 small cubes with no face painted at all. Okay, so basically when you have a cube or cuboid of side A into B into C, the number of cubes with no face painted is given by a minus 2 into b minus 2 into c minus 2. So that's what we are going to use over here. So the cuboid was 7 into 5 into 3. So it is going to be 7 minus 2 is 5. 5 minus 2 is 3 and 3 minus 2 is 1. So there are going to be 15 cubes that are going to have no face painted. So that is going to be this. So this statement is true. So if first statement is true, then second is false. This is also false. Now I need to check for the second one. There are exactly 6 small cubes with exactly 2 face painted. One painted with blue, another painted with green. So blue and green should be here. Okay, because the bottom one is blue and this side one is green, so you are going to get blue and green over here. And in this side you are going to get 3 cubes, and out of 3 2 are going to be corner cubes. Out of 3 2 are going to be corner cubes. So this corner cube must be painted green, blue and red, all three. So we cannot consider the corner ones. So how many cubes we are going to get that are exactly 2 face painted? That is 1. So this is one side. This side you are going to get another one. On the top you are going to get another one, and here you are also going to get another one. So how many cubes you are going to get with exactly 2 face painted? That is going to be 4. Okay, so basically this statement is definitely going to be false. So both can't be true. So answer of this question becomes option A, that is 1 only. Okay. Now let's move on to the next one. What does it says? It says the letter of the word incomprehensibilities are arranged alphabetically. Okay, so it is saying arranged alphabetically in reverse order. Okay, now that's a tricky one, and I wouldn't say it is a tricky one. It is just unnecessarily lengthy. So in hen C B I L I T I E and S. Now it is not reversed. The question is not saying you are just reversing it. The question is saying it is arranged alphabetically, then it is arranged in reverse order. So alphabetically, if I am going to arrange the alphabets, so first is going to be B because A is not there. So B goes to in the back. Okay, so B is done. Then C is here, so C comes here. Okay, then we have D. D is not there, so next look for E. So E comes here. Then so one E is done. Then there is second E. Second E comes here. So basically E is here, E is here. Then what else? And there is one more E. So this is done. Okay, so we got till this point. Okay, so B, C, E, then F is not here, uh, G is not there, then it comes to I. So how many I's we got? One, uh, two, three, four, and 5 I's are there. So one, two, three, four, and 5 I's are there. Okay, so I is done. It's okay. Okay, so I is done. Okay, 3, 4, and 5 I's. Okay, so I's are done. J is not there. K is not there. L is there. So L is here. So L comes here. There is only one L. Okay. M is not there. So N should be here. So N is here. N is here. We are going to get one N over here. One N over here. Then O should be here. Then P should be here. R. Then I'm going to get 2S. 1S is here. 1S is here. So basically after that I'm not going to write anything. And why I'm not going to write anything? Because after that these alphabets cannot be similar to these alphabets, right? So basically how many alphabets are taking the same position? One, I can say this I. Second, I can say this I, and apart from that, there cannot be any other alphabet that can take same position. So answer of this question is going to be option C, that is 2. Okay. Now let's move on to the next one. What does it say? There are large number of silver coins, 2, 5, 10, 25, and 50 grams. Consider the following statements. To buy 78 grams, one must buy at least 7 coins. Okay. Second says less than 7 coins. Okay. So to get 78, there are only two possibilities. Either you are going to use 7 or more, or you are going to use less than 7. Right. So both the statement cannot be true. Either one will be true or second will be true, and so that's why I can directly eliminate both options, because both can't be true, both can't be false, because both are complementing each other. So if first one is false, then second one must be true. If second one is false, then first one must be true. So let's figure out. Okay. So if I am saying that I want to minimize the number of coins to make 78, so what I'm going to start with, I'm going to start with 70, 50. Then I'm going to go with 25. So I got 2 coins till 75. Now I need 3. So 3, can I get 3? No, 3 is not even a possibility. So basically, this arrangement that we were trying to make is not going to work out. Then 50 plus 10 plus 10, 70. Now I need 8 more grams. So how can I get 8 more grams? That is 2 plus 2 plus 2 plus 2. So how many coins I'm going to need to make 78 grams? It is going to be 7 coins. So first statement, this should be true, because at least 7 are needed to make 78 by these. So answer of this question is going to be 1 only. Now let's move on to the next one, and with this we conclude this session. Thank you. So if anyone has any doubt, you can drop me a message on the chat box or comment box, and we'll respond.